Okay, now we're going to do a couple of talks on the big data imperative. We're taking two different points of view. The first is the academic perspective, which will be given by Dr. Elan Sasson. And then we'll follow that with an industrial perspective by one of our IBMers here in the team. All right? So Dr. Elan comes to us from Tel Aviv University. He's a recent new PhD, I understand. But he's also a longtime technologist entrepreneur. So this should be an interesting perspective.
Thank you. You can hear me, right? All right, great. Thanks for inviting me. I'm really excited to be here. Let me start with a question, a provocative one, I should say. How many of you call themselves data scientists here in the hall? Right. Well, I got 3 mark in the end, right? 3 of them. How many people of you have the title on their business card, data scientist? Just 1. Great. I think this has raised some concern because we are the one who's supposed to teach big data and data science, right? And I think it's really prompt the next question is how can we get started teaching a wide-ranging interdisciplinary field that, first, has not established itself as a solid and a deep academic discipline, and second, is so clouded in hype. So the connection between big data, data science, and versus academia is undeniably evident. I mean, there is a clear correlation between established topics from the academia, such as statistics, machine learning, data mining, text mining, information extraction, information retrieval, data visualization techniques, SNA, social network analysis, optimization, and database architecture, to name a few, which are a big relevance to data science and big data. So, given the challenges and the opportunity that we are in the academia face when it comes to data science and big data, I believe that there are 3 major questions to be asked. The first question is why? Why should we be educating or educate our student data science? And why it is important to do that? Second question is when is the right time to start? The timing question. Should we wait for this topic to get established, or should we start at this very time? And the last question is what should we do in order to succeed in this mission? I transfer the 3 V's from the big data to the 3 W's, just I'll be able to remember that. So let's try to give some aspect to each of these questions. So the first question is why? Well, big data and data science are very in a hype nowadays, and we cannot really avoid it. It's the geek chic in the headlines everywhere. Harvard Business Review called the data scientist the sexiest job of the 21st century. Right. The Wall Street Journal said that the data crunchers are now the cool kids on campus. So there is a hype there that we cannot really avoid, and we have to listen to that hype and react upon. Other than that, students pursuing the field of data science. I mean, there is a big it's a problem of demand and supply, and we are on the supply side, and probably we have to do something about it. So we have to educate in what is likely to be a new profession in the industry, and well, we all know the quote from McKinsey from 2011, shortage of 100 to, I don't care about the numbers, but just get the idea that we have shortages with deep analytical skills, and as well as 1 million managers analytics to analyze big data. So we have really to help create effective workforce that of a big data problem solver for a problem that we don't even know how to describe. And we have to teach them a set of skills that is highly on demand in the business environment. Other than that, data science has the potential to be a research discipline by itself, right? So there is actually a new field emerging and that needs to be that need to be thought. And there is opportunity for us to help defining this new field. Just take, for example, statistics. Okay, statistics in the academia and statistics in the industry, it's two different statistics. In real life, clean data set will never be handed to you. There is engineering and technology pipeline to take into consideration how to deal with the data, how to accumulate it, how to pre-process it, how to cleanse it. In statistics, it's you have the data and you run it and everything is fine. So there was a paper at 2001, a decade ago almost, by Bill Cleveland that was titled "Data Science as an Action Plan for Expanding the Technical Area of the Field of Statistics." We had to wait maybe 11 years before this paper became relevant, but this is a call for a change in curriculum when it comes to statistics. Data science is not just happening in industry. This is something very important to remember, all right? Scholars struggles with large amounts of data and computation challenges, and we had the last discussion that was showing that in a clear way. In diverse research fields such as physics, biology, genomics, urban planning, medicine, healthcare, and so on. And they need access to tool developing in the industry. So they need to be trained and in best practice in design patterns which emerge from especially from the industry. Last but not least, I believe it's very important when it comes to ethics. Ethics concern me a lot. And I really don't expect, corporations such as Google or Facebook to be concerned about ethics unless there is regulation about it, okay? And the government, should I mention something about the NSA scandal, okay? Is it ethic to tap on the German Chancellor cellular phone? So let me not comment on that. So that's why I believe that we in the academia should be in the front line. We are the ones that have to initiate ethics guidelines to be integrated into the public policy. We should take an active and leading role in educating students about how to use user-level data privacy concern, such as sample data ethically. Sensitive data should not be held at all. Moreover, limit use of the data, unspecified purposes should be forbidden at all. And specify the purpose of the data. So data no longer serve as a purpose, should be destroyed, not archived, or used for other usage that we are not aware of. Having discussed the why, I think the next question is the when. When should we start? And we have to start right now. I mean, there are new academic programs in data science all over the world. Universities are building and related new courses and curricula. New academic center about big data science. I mean, there is a lot of them, I'm sorry, coming in and popping up lately. And we are in Ben-Gurion University. We recently launched two graduate master program. One of them is by the industrial engineering, and the other one was by the information system engineering. And I think Mark Last will probably talk about it in his talk tomorrow. And in Tel Aviv University, we also launched a graduate master program in data science. But I wanted to really talk to you about and tell you about my own experience. Motivated by this trend, about a year ago, I decided to develop an undergraduate elective course called Big Data Analytics. And it was given last fall. 22 students from the engineering faculty showed up to the class, and there was no prerequisite other than mandatory IS courses, which I found not very helpful for me, because I had to go and teach them data mining and machine learning for almost five classes, which took a lot of a portion of the time that I have to devote to it. So the challenge is that how can we teach a course where the topic is still getting defined in both academia and the industry? Second, I needed to do a kind of mitigation between the tension of the industry and the academia. You know, in the industry, there is a chaotic landscape of tools and best practices versus established research fields. Okay, and everything is still evolving, and we see a lot of startups doing many great things about it, but still it's not well defined. And then finding a textbook or well-defined body of knowledge. There is no one textbook. Okay, I found myself with 10 textbooks. I got really panicked. No, I'm kidding. No, I'm not kidding. I really was panicked. And then I tried to figure out how I'm going to put it all together. So this is really was a tough challenge, especially for me. I was concerned with few major central questions. First, what is a data science, and what is a data scientist does? Second, what does data science mean? And then, is big data equal data science? Or maybe is data science is the science of big data? And then I have to come up with two definitions. What is data science and what is data scientist? So data science was easy. I have my own working definition, but yours is good as mine. So I decided to call it the study of the space of problems solved with data and extreme scale analytics. When it comes to the data scientist, I was having trouble, so I decided to adopt Josh Wills, from Google at that time. Data scientist is a better at statistics than any software engineer, and better at software engineering than any other statistician. I can live with that. So, and then I tried to come up with a list. Data scientist task. What should I learn? Okay. So I have to go through and teach the student about business insights, and then do some data-driven decision making, and building data models, and then do some visualization, dashboard, maybe key performance indicator, and so on. Going to statistics, basic, correlation is important, and do some programming, introducing map-reduced transformation, Hadoop, and so on, schema-less non-relational databases, okay? Data mining, machine learning, text mining, information extraction, natural language processing, information retrieval, graph mining, and large-scale network analytics, visualization techniques, and then how to tell a story. You get the results, you want to tell a story. The story has to be equipped and be appealing. So it was a huge challenge for me, and I'll tell you this much. The course final project, by the way, was doing something in text mining, data mining in R, in Rattle. And then we have another assignment using Facebook network, using the Gephi, the open source Gephi. And you know, I have some reflection about this. First, my own data science definition keep extending toward version 2 of this course, which I'm going to give next semester. But you know what? I was really naive to believe that I would be able to squeeze it all in one course. I mean, the students complained, as a matter of fact. They told me that I made them to work a lot. But surprisingly enough, they came to me at the end of the course and they said, "Listen, it was nice. You know, we really enjoyed it." And that was a big sign that I'm on the right track. But I have to prove myself and improve myself a little. So the last question, not the least, but I think the most, I would say, challenging aspect is what should we do? And this has to do with the fact that there is, when we come to the data science domain, there is a diversity of expertise and knowledge required, and no one person can be perfect data scientist. I mean, it's required teamwork. And not just a teamwork, it's interdisciplinary teams with a mixture of background and skills. So the learning environment, the traditional learning environment that we are used to, I'm not sure whether it's ideal for training the next generation data scientists. And I think that the traditional teaching environment should be revised. Okay. First, we have to modify and the concept of lecturer as a sole knowledge provider to knowledge mediator. Okay. We don't have the whole knowledge to transfer, to provide with our student. So we do a kind of mediation of the knowledge. Second, we have to do a co-lecturing and co-teaching, okay? With academic experts in specific related fields, giving the diversity in the field that we are faced with. Then we have to cooperate with the industry. Big data, it's happening in the industry, okay? It's out there. I usually say that when we come to the enterprise, it's big data, but it's B&D, not capital B and D. Only in Facebook and Google and Twitter, they have the big data with capital B and D. So we have to cope with industry expert, with guru, and can bring them to the class and have them describe use cases so the student will be able to understand what is the big data all about. Also, I believe that we have to educate students to be a consumer of knowledge, okay? Expand the learning experience with related online courses, MOOC, massive online courses such as Coursera, MIT Open Courseware, Stanford online courses, Khan Academy, and so on. And we have to also establish an interactive user forums and collaborative community learning environment for students, for teaching assistant, for professor, for lecturers from all over the world. Coursera, by example, if you happen to go to Coursera, to Andrew NG, Introduction to Machine Learning in Coursera, we had, I think, the last time he was giving the course, it was about 100,000 students all over the world. So imagine what kind of communities is that, and they really communicate with each other. It's a big, huge forum. We cannot have this in class with 22 students, right? And self-paced learning environment, as I mentioned before, in my course, they had to learn the R platform by themselves. I give them an introduction of 30 minutes, and I tell them, listen, you have to go to the web. There are plenty of information, online tutorials. You have to do it all by yourself. So this is a self-paced learning environment. Which also has to do with the revision of the traditional learning environment that we are used to. And I think we have to come up with this one. From the sage on the stage to a guy on the side. That's what we are going to be probably in the near future. Having discussed some aspect of why, when, and what, and I hope that I convince you, I think the takeaway message from here is that it's necessary for us to quickly modify and update our core curriculum and courses to provide students and other scholars as well the skill set needed to become a data scientist. So thank you very much.